All right, so today we worked on Chapter 4, Section 4, decimal division, and these are the problems. I want to do just a little work prior to walking through the solution to the problems that we have here. I wanted to sort of remind you of the notation that we're using. And you might say, what does that mean? We kind of always just simply say decimal and stop there. This really is a shortened name for decimal fraction. And you remember we discussed fractions in the earlier chapters, and we said, without going into too much review, that a fraction is a way to basically measure a quantity that's less than one whole. And in that notation, we allowed ourselves to have any denominator, that is, any divisor or any value that we wanted to specify the number of items that it took to make the whole. That is, how many items have we divided our whole into. Now, decimal fraction really is just another way to think of fractions where the denominator of the fraction is either 10, 100, 1,000, and so forth. So as the decimal place values proceed from, here are my ones, and then I have the first decimal place, which is the tenths, and then the next is the hundredths, and the next is the thousandths, and so forth. Just remember, we're still using the idea of a fraction. We're just allowing ourselves to include it in our base 10 numbering system so that we use an extension of the idea that as we go to the left, we're getting larger by a multiple of 10, and as we go to the right, that is less than 1, we are subsequently dividing things by multiples of 10. In other words, we start off 1/10, so we have some item divided into 10 pieces, then we have that same item, we can divide it into 100 pieces, and so forth. That carries over into this idea of how we handle decimal division. Now, the way that we will normally describe this is we'll just simply say, if the divisor, and let's review this for a second while we're at it. So this is the divisor, this is the dividend, this is the work, the answer is a quotient, and in whole number division and fraction division, we wound up discussing the idea of a remainder. What we do with decimal division is we add some zeros and we just continue our division process until we decide whether or not we have a terminating or a repeating decimal value. But at any rate, the terminology is going to be the same terminology. So in this problem, the divisor is 7. The dividend is 2 94/100. And the way that we teach this is we say, well, where's the decimal point in here? Oh, and this is a whole number divisor. And we're going to find that when we have a decimal divisor, we're going to have a little different treatment. But this is a whole number, so what do? I look here, and there's decimals here. So I carefully place this decimal point here, and then proceed along my way. And I say, well, that's 28. 1, that's 2. Remainder of 0, and I'm done. And so the answer to this first one is in fact B, 4200ths. Now, I want to just take that one more step to explain to you exactly why this whole thing of moving the decimal up and the mechanics that we're going to use work. So see if this is something that you get. So 2.94 divided by 7, that's what their problem was, 2.94 divided by 7. Now I'm going to make some changes here. 2 and 94 hundredths. So I suddenly converted this from decimal notation to fraction notation, where I'm taking out the idea that this is a decimal fraction and its denominator is 100. I'm now going to divide by 7. Yep. I'm now going to do this. Remember that? I converted this now to what we would call an improper fraction. This was a mixed number. Now it's an improper fraction. Still, the denominator is a 7. Denominator is 100, I'm sorry. Dividing by 7. Do you remember this? What did I just do? Well, this is fraction division, and you recall when we have fraction division, what do? We do the keep, change, flip. Keep this, change this to multiplication, and flip this. So this has got a 1 under it. Now, I'm getting close to the punchline. This now is going to become, look, 294 divided by 700. You say, I don't see how you made any progress. I made a lot of progress because what I did is I turned this from a problem that has any decimal division to a problem now that has nothing but whole numbers. And I can do that division. Ready? Except, if I am going to do it, I need to now use decimal techniques. So this now is a whole number, not 294 divided by 700. And yes, with the same conversation we've had before, that after the ones place and the whole number, we start with an implied decimal point here, and we start adding decimal values. So if I need to, I can put zeros out here. So now, notice, let's see, 4, 1, and bring down the next 0, and 700 goes into 1400 2 times, and I get 1400, and I get a remainder of 0. So notice the answer is still 42 hundredths. I just wanted to do this so that you can think about why this whole business of moving decimal points around, as we're going to do in a minute, and why it makes some sense to put this decimal point directly up here. I wouldn't expect you to ever go through this process here to do this division problem. I would expect you just to do what I did up here and get 42 hundredths. Now, here's the next one, and it is a slightly different problem. It is 3.4 divided by 0.04. So let me copy it down here. It's 0.04, 3.4. I'm going to do the same thing I did a minute ago. I'm going to tell you that this is 3.4 divided by, and I'm just going to use only the decimal amounts here. Now, what can I do now? Well, let me stop here because I want to show you what we would have told you to do if you had this problem with no other instructions or no other example. What we would have said is you move this decimal point 2 places to the right and move this decimal point 2 places to the right, so that what we do is we have a whole number divisor. So the instructions have always been, if you have a decimal divisor, you convert it to a whole number. How do you convert it to a whole number? Move decimal point, number of places required to turn it into a whole number. So this problem now becomes 4 into 340. So we've changed our problem now to a nice whole number problem. We have no decimals except perhaps at the end. And how do we do this? Well, 4 times 8 is 32. 4 minus 2 is 20. 4 goes into 25 times. 4 times 5 is 20, remainder of 0. And so the answer to this one, 2, would be A, 85. So here I'm looking for it. So here it is. The answer to 2 is 85. Can you see that over here? The answer to 2 is 85. Now let's come back to this approach. You ready? So I'm going to say this is 3 4/10 divided by 4 hundredths. Ready? This is now 34 tenths divided by 4 hundredths, right? Keep change flipped. 34 tenths times 100 over 4. And what does that give me? Gives me 40 into 3,400. And if I do long division for that, what am I going to get? Well, 40 will go into 348 times, which is 320. 40 goes into 205 times, and I'm done, and I still get the answer of 85. So this is one other way you can think about doing these. Now, there's yet another way you could think about it, which is, notice, you could say to yourself, well, how many times, or what did I have to multiply this by to turn it into a whole number? So let me show you this. Okay. Then you say, okay, what are you going to do now? What I'm going to do now is I'm going to say, I would like for this to become a 4, just a 4. How can I make it become a 4? Multiply by what, 100? Because multiplying by 100 does what? It moves the decimal point 2 places to the right. So if I multiply this times 100 and multiply up here times 100, I'm now going to get 4 into 340, which is also going to be 85. So the normal method we would describe for you to do this is we would just simply say, move the decimal point to the right the number of places so that you create a whole number divisor. Also move the decimal point in the dividend the same number of places, and you wind up getting this. If you went all the way back to thinking of these in terms of their decimal fraction notation, which would be 3 and 4 tenths, and 4 hundredths, this would be 3 and 4 tenths, 4 hundredths, 34 tenths divided by 4 over 100. So you keep change flip notation, and you also get 85. I hope this doesn't confuse you. I'm just simply trying to give you just a little bit of the logic behind why moving this decimal point around works. So here we go. Without much more conversation, this one is a decimal divisor into a decimal value. I'm going to move the decimal point 2 places to the right, 1, 2, turn this into 2, move this one 2 places to the right, turn this into 180, and the answer is going to be 90. So the answer to number 3 should be D. The answer to number 3 is, in fact, D. Number 4, these are all going to be similar. This one's just going to be a little more tedious because it's bigger numbers. This is 3.7. Move it 1 place to the right, turn it into 37. 1 place to the right, turn this into 1.813, and then start dividing. Well, 37 goes into 0, into 1, 0. 37 goes into 18, 0 times. I finally get 37 into 181, which turns out to be 4 times. And I then proceed down along with my long division process, and I ultimately get to an answer which is 0.049. I think this was a 7 here. So I was down to the point of 9 times 7 is 63. So that was 330. 9 times 7 is 63. Well, I did it over here. Where did I do it over here? Yeah, here it is. 9 times 7 is 63, and 37 times 9 is 306. So I came to here and did this subtraction, and then I got 270. The question is, how many times will 37 go into 270? And what was it? 7 times? 7 times 7 was 49, and I kept going. So I got to 0.0497, And I noticed that at that point, the only answers I had that were going to work was going to be either, well, this was only one, 0.049, because they didn't go any further. Had they asked me to round this, excuse me, I would have had to have gone to this place and round it to 0.050, but none of these other answers seemed to require rounding. So I concluded that the answer to number 4 had to be C. And you can tell here the answer to number 4 is, in fact, C. Number 5 is same thing. Move decimal point 2 places to the right. Decimal point 2 places to the right. Move this one 2 places to the right. Now, it's a whole number, but because I moved this decimal point here in the divisor, I had to move it here. And I wound up getting 200 is the answer. And the answer to number 5 is C, which was also correct. 5 is C, which is 200. This next problem is an example of one where we had a fairly simple equation to solve, and we've done these kinds of equations before. What if I told you that the equation was 3 times Q is 6? Well, you can tell that that's 2, but systematically, how can you do that? We'll divide this by 3 to get Q and divide the other side by 3 to get 3Q divided by 3 is Q, 6 divided by 3 is 2, so I find that the value is 2. We'll use the same idea here. This says divide both sides by 0.08. So I wound up dividing 3.6 by 0.08. Same thing. Decimal point goes 2 places right. This one goes 2 places right. And I get 45 as the answer. So the answer to number 6 is A, I think. And the answer to 6 is, in fact, A. Now, these can be a little more tedious because you just got to be careful with doing these in the order of operations sequence. You do the work inside the parentheses, then the exponents, multiply and divide in order from left to right, and then before you do your adding and subtracting in order from left to right. So you'll notice what happened here. We did this subtraction first, and we got 4.2. We then squared it and got this. Then we're going to do the division next, right, and get 4.41. Then we'll do this multiplication and get 4.08, and then add them together and get 8.49. And so the answer to 7 was, in fact, C, which is 8.49. And then this last one was just, we had to do a little addition and then a little division. And let me see if I can find where we did that work. So here it is. So what we had was, what's the average electricity usage for the months January through April? So January, February, March, April, that would be 4 months. And they gave me the data for each of those months. So I simply added them up here and then divided by 4. This was not hard. Didn't really have to worry too much about the decimal until I got to the very end here. And then I got 977.55 was the answer that we had for that one. And so that was C. 8 was C. And here was the answer here. 8 was C. So we added these up, then divided by 4. Again, when you're adding decimals, if you're doing it by hand, just be careful with the alignment. Nothing new here. This is just a whole number divisor going into a decimal. And we did, in fact, at this point, it looks like we did, in fact, add a 0, didn't we? Yeah, we wound up adding a 0 out here, and we wound up getting 20, and we had it terminated. If you wanted to check this, 977.55 times 4. 4 5s is 20. 4 5s is 20, 22. 4 7s is 28, 30. 4 7s is 28, 31. 4 9s is 36. And 3 is 39. And I do, in fact, count off 2 places. I get 3910.20, which is what we had before. So that answer was correct. All right, so not too difficult.